Every year, the American firearms industry produces millions of AR-15 rifles, an almost staggering figure when we pause to consider the complexity and precision required for each one. Behind those numbers lies a sweeping story of invention, technological breakthroughs, heated debates, and global influence. This rifle, once a brainchild of a single engineer, has turned into a household name. As we trace its path from the drawing board to assembly lines cranking out countless units annually, we uncover not just a manufacturing marvel, but also a lens into American culture, identity, and controversy. From the outset, the AR-15's explosive popularity may seem surprising. After all, how did a single firearm design manage to dominate modern shooting sports, spawn endless variations, and ignite passionate debates? To answer that, we have to roll back the clock to the 1950s. When a former Marine by the name of Eugene Stoner was quietly at work, revolutionizing the way modern rifles were built. At that time, the traditional approach to firearms still relied heavily on steel and old-school manufacturing methods. Stoner flipped that on its head by experimenting with lightweight materials like aluminum and innovative gas-operated mechanisms that reduced recoil. He was initially focused on military contracts, leading to a rifle known as the Armalite AR-10. But it was a scaled-down version, originally pitched for selective fire military use, that would later be adapted into the semi-automatic AR-15 for the civilian market. In the early days, few foresaw just how popular the AR-15 would become. But the moment civilians gained access to it, the industry saw a glimmer of something revolutionary. The rifle's modular design made it infinitely customizable. Enthusiasts could swap out upper receivers, barrels, handguards, stocks, and a dizzying array of attachments, all without extensive gunsmithing knowledge. This level of personal customization, combined with relatively light recoil and user-friendly ergonomics, propelled the AR-15 to center stage in the firearms world. Manufacturers quickly recognized a golden opportunity. Through savvy marketing, they showcased the rifle not just as a tool but as a platform, something that could be tailored to hunting, target shooting, home defense, or professional use. Word spread, demand soared, and the AR-15 began its meteoric rise. But how exactly do companies keep pace with producing so many rifles? To understand the scope of high-volume production, you first have to envision the bustling environment of a modern firearms factory. Picture rows of computer-controlled machines, CNC mills and lathes, humming away as they carve precise contours into aluminum forgings. These forged aluminum blanks serve as the foundation for both the upper and lower receivers, arguably the heart of any AR-15. Each forging is loaded into a machine that systematically removes material with micron-level precision. The computerized process ensures every interior channel, pinhole, and attachment point lines up perfectly, part after part. Once the receivers are machined, they undergo a surface treatment known as anodizing. During anodizing, the aluminum is submerged in an electrolytic bath that changes the material's surface on a molecular level. This not only creates a tougher outer layer, but also improves resistance to corrosion. Anodized receivers emerge with that familiar matte finish that so many AR-15 owners recognize. Meanwhile, steel components, like the barrel and bolt carrier group, take a different route. Some are chrome-lined, a process that provides extra durability for parts exposed to repeated combustion and extreme heat. Others are nitride-treated, which further hardens the steel and fights off wear. These treatments might seem like small details, but on the production line, they represent critical steps that maintain reliability in millions of rifles used over countless shooting sessions. All of these processes must be meticulously choreographed if you're aiming to produce hundreds of thousands or even millions of rifles in a single year. Delivery trucks arrive hauling raw materials, aluminum and steel in various grades, polymer resins for stocks and grips, and smaller components like springs and pins. Floor managers coordinate supply chain logistics, ensuring that each assembly station has exactly the right parts at the right time. Advanced inventory systems track every item from the moment it enters the facility until the final rifle is packaged. Any minor miscalculation could slow production or compromise quality. Despite the scale, top-tier manufacturers maintain a rigid standard for quality control. After all, any defect in a firearm can have serious consequences. What's truly fascinating is how technology continues to refine this assembly process. Today's factories often use robots for repetitive tasks like applying adhesives or precisely inserting small pins. In parallel, some companies employ 3D printing, not just for prototyping, but for producing jigs, fixtures, and even small batch parts that might be too complex for traditional machining. Engineers use finite element analysis software to stress test components long before they see real-world use. By simulating thousands of rounds in a virtual environment, designers can predict potential weak points, tweak geometries, and improve material selection. It's this constant cycle of innovation, design, test, refine, that ensures manufacturers can consistently roll out new and improved AR-15 models. Hand in hand with these high-tech methods is the emphasis on material science. Aircraft-grade aluminum forms the backbone of most AR-15 receivers, prized for its lightweight and robust strength. Meanwhile, advanced polymer blends are used in grips, stocks, and forends, allowing for ergonomic designs that won't crack under recoil or varying temperatures. Engineers push these materials to their limits. Some labs subject them to freeze-thaw cycles at sub-zero conditions, while others run them through salt spray chambers designed to accelerate corrosion. Only those materials and finishes that survive these torture tests make it into final production. Given all this precision, one might ask why the AR-15 ignites such strong feelings. Part of its cultural significance stems from the fact that it's deeply woven into the larger American debate on gun rights. For many, it's a symbol of personal freedom, the ultimate expression of the right to bear arms. Enthusiasts argue that the AR-15's adaptability, accuracy, and comparatively mild recoil make it an ideal choice for everything from sporting competitions to home defense. Opponents, however, point to the rifle's involvement in certain high-profile incidents, fueling ongoing discourse over regulation and public safety. News headlines often highlight the AR-15's role in national controversies, turning it into a lightning rod for conversations about responsible ownership, legislative measures, and the broader societal impact of firearms. Regardless of which side of the debate individuals stand on, it's undeniable that the AR-15 has become more than a tool. It's a cultural icon and a perpetual talking point. If you look beyond the headlines, though, you'll see that the AR-15's story is far more complex than a simple political symbol. It represents decades of engineering evolution, mass production ingenuity, and market dynamics. The gun industry is heavily competitive, with numerous companies vying to produce their own spin on the platform. Some focus on budget-friendly models, using cost-effective materials and bare-bones designs to meet an entry-level price point. Others specialize in high-end, precision builds, incorporating match-grade barrels, specialized triggers, and advanced coatings. This wide-ranging ecosystem is precisely what enables the AR-15 to appeal to a huge variety of consumers, each with their own reasons for wanting one. Looking forward, the future of AR-15 production appears poised for further technological leaps. Some companies are experimenting with carbon fiber components, offering even lighter builds that maintain structural integrity. Others delve into polymer-cased ammunition to reduce weight and heat buildup, which could influence barrel design and overall rifle architecture. Regulatory environments also shape innovation, as changing legislation might push manufacturers toward new features or production methods. For instance, certain states impose restrictions on specific components, leading to featureless models that comply with local rules. Meanwhile, 3D printing technology sparks conversations about decentralized manufacturing, raising both excitement and concern. If hobbyists can print functional components at home, what does that mean for mass production and traditional supply chains? Then there's the market for accessories, which is almost a universe unto itself. Red dot optics, magnified scopes, backup iron sights, custom muzzle devices, specialized foregrips, bipods, and more flood the marketplace, each with its own design philosophy and brand loyalty. Much like how smartphone users buy cases and apps to tailor their devices, AR-15 owners can pick and choose from thousands of aftermarket options to create a firearm that matches their specific needs or aesthetic preferences. This vibrant accessory landscape is another key driver behind the astronomical production numbers. After all, someone who invests in customizing one AR-15 often ends up wanting a second or third platform configured differently. That cyclical nature of interest and customization fosters steady demand and continuous innovation. Despite the massive popularity, numerous myths and misconceptions swirl around the AR-15. Some believe it's solely military grade, conflating the semi-automatic civilian models with the fully automatic M16 or M4 used by various armed forces. Others think that the design is overly complicated, only to discover that field stripping and cleaning are actually quite straightforward. There's also confusion about the name AR-15, with some interpreting AR to stand for assault rifle, when in fact it references Armalite rifle, the original designer's brand. And then there's the persistent question of safety. Critics wonder whether a platform so easily customizable could contribute to irresponsible use, while proponents counter that millions of law-abiding owners rely on AR-15s for legitimate purposes without any issues. Each of these debates is filled with nuances, personal experiences, and deeply held beliefs, making the rifle's cultural footprint even more diverse. In the midst of these arguments, the production lines continue to hum. Day by day, new shipments of raw materials are delivered, forging machines stamp out fresh batches of aluminum blanks, and CNC mills transform them into receivers within a matter of minutes. Technicians meticulously measure tolerances, watching for any sign of deviation. Assemblers fit together the barrel, bolt carrier group, trigger assembly, and countless smaller parts before test firing each completed rifle. Any flaw, no matter how small, risks tarnishing a manufacturer's reputation, so the standards remain remarkably high. And still, the final products number in the millions every single year, ready to be shipped out to distributors, then onto local gun shops, and eventually into the hands of eager buyers. It's also important to acknowledge that the AR-15 is not a monolith. There are countless spin-offs, clones, and variations bearing different names but sticking closely to the mil-spec, military specification design. These can include rifles chambered in various calibers, from .22 LR for inexpensive target practice to .300 AAC blackout for specialized hunting applications. Some models sport long barrels with free-float handguards for precision shooting at extended ranges. Others come in ultra-compact configurations for tight maneuvering. Specialty triggers, competition-grade muzzle brakes, and advanced optics can further transform the rifle's handling. The possibilities are nearly endless, and this adaptability ensures that the AR-15 remains a top choice for enthusiasts looking to build something uniquely their own. As technology keeps progressing, we might see even more radical departures from the traditional AR-15 blueprint. Carriers made from exotic alloys could reduce friction and wear. New polymer blends might replace even more metal parts. And integrated electronics, such as heads-up displays or advanced ballistic calculators, could eventually become standard. Experts are already exploring ways to incorporate recoil mitigation systems that make shooting smoother than ever. In parallel, the emergence of smart gun technology raises questions about whether some AR-15 models might incorporate biometric locks or advanced safety features in the future. Though such ideas are greeted with skepticism from certain segments of the firearm community, the mere possibility indicates that the AR-15's evolutionary path remains wide open. Beyond the hardware, the conversation also includes the social aspects tied to owning, shooting, and manufacturing AR-15s. Firearm training schools often use them as the default platform to teach new shooters about safety, maintenance, and accuracy. Gun clubs host specialized competitions that revolve around the AR-15, pushing participants to test their marksmanship and speed under various scenarios. Meanwhile, local and federal policymakers frequently reference the AR-15 in legislative proposals, reflecting its emblematic role in discussions on public safety. Researchers in criminology, sociology, and public health track how public opinion on this rifle shifts over time, parsing the data for insights into national attitudes. Whether one views it as a beneficial tool or a contentious product, the AR-15's widespread presence ensures it remains at the forefront of both industrial production and societal debate. In all this complexity, it's valuable to remember that the AR-15 is ultimately a piece of technology, one that has been refined, reimagined, and mass-produced for decades. It didn't become a cultural juggernaut overnight. Rather, it followed a trajectory shaped by historical events, consumer demands, and ongoing innovations. From the first prototypes sketched on a draftsman's table, to the ultra-modern assembly lines that now crank out thousands of rifles per day, the Ar-15's journey encapsulates the story of American manufacturing at its most ambitious. It's a tale of how a single invention, if well-timed and sufficiently adaptable, can transcend its original purpose to become an enduring fixture in society. As we near the end of this exploration, the question arises, what does the Ar-15 signify moving forward? For manufacturers, it's an evergreen opportunity, a product with steady demand, diversified uses, and a seemingly endless capacity for modernization. For policymakers and community leaders, it's a recurring topic in wider discussions on regulation, security, and rights. For everyday enthusiasts, it's a platform that can be fine-tuned to their heart's content, whether for competitive shooting, hunting, or personal defense. And for the broader public, it's the subject of curiosity, debate, and at times, strong emotional reactions. One truth stands out. As long as firearm ownership remains a core part of many people's lives, and as long as technology keeps pushing boundaries, the Ar-15 is likely to stay front and center. Each year brings fresh design tweaks, new engineering feats, and reimagined approaches to safety and function. With millions already in circulation and more rolling off the lines daily, it's fair to say that the Ar-15's legacy is still being written. And in that ongoing narrative, every component, every round fired, and every heated discussion plays a role. In conclusion, the Ar-15 is far more than a mere rifle. It's a microcosm of modern manufacturing, where automation, precision engineering, and rigorous quality control intersect to produce a consistent, standardized product on an immense scale. It's also an emblem of cultural identity for many Americans, both fervently supported and vehemently criticized. And it's a platform of unending adaptability, one that continuously spawns fresh innovations and niche specializations. Whether you admire it, question it, or feel a mix of both, there's no denying the Ar-15's profound impact on firearms technology, public dialogue, and the ongoing story of how tools shape and reflect the people who use them. As time progresses, new generations will discover the Ar-15, each bringing its own perspectives and innovations. Where we stand today is the result of decades of transformation, from Eugene Stoner's prototype to the mass-produced phenomenon of the present day. And still, the story marches on. Perhaps in the coming years we'll see breakthroughs that reduce weight even further, mitigate recoil to near zero, or incorporate data-driven features that assist shooters in real time. Just as the Ar-15 of the 1950s would be unrecognizable to modern eyes, the rifles of tomorrow may bear only a passing resemblance to what's on store shelves today. Yet, the essence of modularity and customization that made the Ar-15 famous is likely to remain at the core of every new iteration. In the broader conversation, the Ar-15 serves as a constant reminder that no piece of technology exists in a vacuum. Every innovation, no matter how brilliant or useful, interacts with the culture around it. That is the paradox of the Ar-15. It's at once a piece of machinery shaped by user preferences and a cultural symbol that influences those preferences in return. Its evolution continues, each generation of rifles building upon lessons learned from the last, and each new wave of shooters adding their voices to the tapestry of opinions. Whether you consider the Ar-15 a masterpiece of engineering or a point of contention, it's undeniably a phenomenon, one that will likely remain in the spotlight for years, if not decades, to come.